Today we are going to discuss a question regarding Fresnel integral. The question is, show that the Fresnel integral 0 to infinity sin x square dx converges conditionally. We know that the integrand sin x square is continuous on closed 0 to infinity. So by definition, integral over 0 to infinity sin x square dx is equal to limit r tends to infinity integral 0 to r sin x square dx. Now let x square is equal to u and x is equal to root u, then dx is equal to du by 2 root u. Then for any q greater than p greater than 0, we have integral p to q sin x square dx is equal to integral p square to q square sin u du by 2 root u, which is equal to 1 by 2 into integral p square to q square sin u by root u into du, which is 1 by 2 into minus cos u by root u from p square to q square minus integral p square to q square into minus 1 by 2 u raised to 3 by 2 into minus cos u by cos u into du, which is equal to 1 by 2 into cos p square by p minus cos q square by q minus 1 by 4 integral p square to q square cos u by u raised to 3 by 2 du. Now by the properties of absolute value combined with inequalities and integrals and the fact that mod cos u is less than or equal to 1 for all u element of R, then we have mod integral p to q sin x square dx is less than or equal to 1 by 2 into 1 by p plus 1 by q plus 1 by 4 into integral p square to q square 1 by u raised to 3 by 2 du, which is equal to 1 by 2 into 1 by p plus 1 by q minus 1 by 2 into 1 by root u from p square to q square. Then we get 1 by p. Hence, corresponding to any epsilon greater than 0, choosing a n greater than 1 by epsilon, we get for n less than or equal to p comma q less than infinity. Then mod integral p to q sin x square dx is less than or equal to 1 by p, which is less than or equal to 1 by n and less than epsilon. Since for any r greater than 0, the integral 0 to r sin x square dx exists. Now by Cauchy test, we get integral 0 to infinity sin x square dx converges to a finite real value. Now we are going to prove that the integral diverges absolutely. So again, let x square is equal to u. Then we obtain integral 0 to infinity mod sin x square dx is equal to integral 0 to infinity mod sin u du by 2 root u, which is 1 by 2 into integral 0 to infinity mod sin u divided by root u into du. Since mod sin u divided by root u is greater than or equal to 0 for all u element of 0 to infinity, we are going to apply a lemma, which is for f of x greater than or equal to 0 at an interval a to c, integral a to c f of x dx is equal to sigma n equal to 0 to infinity integral over an to an plus 1 f of x dx. So here integral 0 to infinity mod sin x square dx is equal to half into integral 0 to infinity mod sin u divided by root u du is equal to half into sigma n is equal to 0 to infinity integral n pi to n plus 1 pi mod sin u divided by root u du. Now for all n is equal to 0, 1, 2, etc., we have integral n pi to n plus 1 pi mod sin u divided by root u du is greater than or equal to 1 by root n plus 1 into pi into integral n pi to n plus 1 pi mod sin u into du, which is equal to 1 by root n plus 1 into pi integral 0 to pi mod sin of t plus n pi dt. But sine of t plus n pi is equal to sin t into cos n pi plus cos t into sin n pi, which is minus 1 raised to n sin t. And mod sine of t plus n pi is equal to mod sin t, which is sin t for all u element of closed interval 0 to pi. Hence we get integral n pi to n plus 1 pi mod sin u divided by root u du is equal to 1 by root n plus 1 pi into integral 0 to pi mod sin of t plus n pi into dt, which is 1 by root n plus 1 pi integral 0 to pi sin t dt. Then it is equal to 1 by root n plus 1 into pi minus cos t from 0 to pi, which is 2 by root n plus 1 into pi. Therefore, integral 0 to infinity mod sin x square dx is equal to half into sigma n is equal to infinity integral n pi to n plus 1 pi mod sin u divided by root u du is greater than or equal to half into sigma n is equal to infinity 2 by root n plus 1 into pi, which is equal to 1 by pi into sigma n is equal to 1 to infinity 1 by root n. Since the infinite series sigma n is equal to 1 to infinity 1 by root n is divergent, and the integral 0 to infinity mod sin x square dx is also divergent. Hence the given improper integral is absolutely divergent even though it is convergent. Therefore it is conditionally convergent. Thank you.